This lecture is on line conventions and multi-view drawings. The line conventions are essentially the idea or the lines that we can draw to convey objects. So changing what those lines look like, whether that's the thickness or the style, can communicate the object's geometry. The first type of line we'll talk about is a construction line. Construction lines are usually very light or pretty thin, and they're used to guide your drawing or to guide where you should put other lines. So in this picture, we've got a construction line that was used to sort of define the boundaries for that arc. And we can sort of see that our arc here has to fit within this. Maybe we know that it's going to be roughly tangent here, roughly tangent here. We can sort of sketch within this general construction line boundary. Object lines are typically thicker and darker than a construction line, and they are what we use to actually make our objects. So they define our objects, they define the outside or any edges or corners of our objects that we can see from that particular view. So if there are any lines that say we can't see from the view that we're looking at, we can show those with hidden lines. Hidden lines are dashed lines that are typically not, they show things that are typically not visible from that object. So you can see this in this picture, we've got two boreholes. So essentially we've got two holes drilled straight through. But it's in the middle of the object, so you wouldn't be able to see it from this front face unless your object was made out of glass or a clear plastic, something like that. So we can use the hidden lines to demonstrate that there is something back there, even though we can't actually see it. We wouldn't actually be able to see it. I'm looking around for an example. I don't have anything great. So you could think about like this tape dispenser. From here, from this view, you can't actually see the bottom of the tape. You can't see that it's a complete circle, but we know that it is. But that would be shown, you could show that as a hidden line, sort of a dashed line demonstrating that this circle of tape exists even though we can't see it from this edge. So a center line is usually drawn with a long dash, short dash, long dash, short dash. And those are going to define the centers of arcs, circles, or any symmetrical parts. Typically, they're not as thick as an object line, but you can see here we have them denoting the center of those holes that were drilled through our object. So the center line is representing that is a cylinder, it's going to go straight through the center. We can also use section lines. So imagine we've got this part here and we sort of saw away a part of it to see what it might look like on the inside. So section lines are those diagonal crosshatched lines that represent that we've sort of cut away part of the material and now we're looking at the inside of it. A short break line is that jagged freehand line we have there that represents sort of the edge where we first cut into our object in order to show that detail. For a lot of these drawings, we can use dimensions. So dimensions are going to tell us the actual size of the object. And these dimension lines are typically shown with arrowheads on either side, and then you would put your dimension or the actual number inside those arrowheads. There are a couple exceptions, but for here we can just assume that the number goes in the center. The arrowheads sort of determine where the dimension starts and ends, and those arrowhead lines are actually connected to our object with extension lines. So these vertical lines I have here are extension lines, and they basically go from our dimension lines with the arrows pointing towards that feature of our object. They don't actually touch the object. They stop about 1/16 of an inch away from the object. And this is because you don't want to confuse the extension line with being actually part of your object. We can also have a long break line, and this is used to shorten objects that have uniform detail. So for example, you can see in this picture, this object is 12 inches long, and if we had drawn it to scale, it'd go way off the paper. So we use a long break line to demonstrate that this sort of pattern continues, but we don't need to show everything, or we don't need to sketch the whole thing because there's no new information. A leader line is used to show the dimensions of arcs, circles, and details. So again, that has an arrowhead on it, kind of like a dimension line, but it's just a single arrow and it's pointing usually towards an arc or a circle. So these line conventions, they relate to technical drawing. So if you're just freehand sketching like in our activity, I'm asking you to sketch, household objects. Those are just freehand sketches. So you don't need to include, you don't necessarily need to include dimensions, things like that. But these are good to use when you are freehand sketching. And they're definitely required for technical drawing. So there is a precedence of lines. Basically, if you have an object and you're drawing it and you notice that, say, a object line occurs in the same place as a center line, so even though the face you're looking at has an object line, maybe it has an edge there, but then deeper inside it has a hole drilled, so you should have a center line. This is sort of the priority for what you would draw on top, or what you would actually see when you draw it. So first are cutting plane lines. If you're cutting something, you would want to draw those cutting plane lines. Those would take precedence over an object line. Second is an object line. Third is a hidden line. So if a hidden line and an object line overlap, you draw the object line. And then lastly would be a center line. So here's an example. In this particular object, this is a multi-view, which we will talk about in the rest of this presentation. But this is the front side view of an object. This is the top, and then this is the right side view. So in this case, we've got a hole drilled straight through. If we were looking at it from the top, you could see we've got our center line here that represents the center of this hole going back into the distance. We would also, if we were actually looking at this from the top, there would be hidden lines to show the edges of this hole. However, we also have object lines made by this cutout. So in this top view, these object lines take precedence over the hidden lines, and you would actually just put a solid line here. Similarly, on this side view, you've got the center line coming over and it overlaps with a step, and you would actually draw that step instead of drawing the center line. All right, now that you had that little teaser on multi-views, we're going to dive into that concept. So multi-views show two or more 2D views of a 3D object. So again, it's a way to think about a 3D object in 2D, but by showing simultaneous views of the object. These are going to provide the shape and description of an object. And if we add dimensions, these are usually what we're going to be giving as engineers to manufacturers. So basically, this is how we communicate. Multi-views are how we communicate our designs that we make to the people who are going to be fabricating them, if it's not ourselves. So here's an example of a multi-view. It's just this dining chair. So this is a pictorial that you may have seen before, but this is a multi-view. So we have the front view of our chair. The top view is drawn on top as though we're looking straight down at the chair. The right side, as though if we peeked over to the right side of our chair, this is what it would look like, and then this is the left side. So you can see the left side picture is on the left, the right side is on the right, and the top is on the top. So these are really useful because it can show the contours. So you know how this is sort of making a little arc right there. You can't really see that from the front view, but you could see that from the side view. So it's really good to show details like that that you wouldn't necessarily be able to see from a single view. Here's another example. This is just a basic object, but in this case we've added some dimensions. So this is what the final product might look like. You have your object that needs to be manufactured, and we need to know exactly what each of those sizes are. So in multi-view drawings, all three-dimensional objects essentially have a width, height, and a depth. So the width is essentially the object side-to-side dimension, the height is the top-to-bottom dimension, and then the depth is considered the front-to-back dimension. So if you have an object, you have to decide what is the front edge of your object, and then you're going to have a width corresponding to that front edge. You want to choose what the top is. The top is going to be located at some height, and then the right side view is going to be drawn with some depth. So if we were to make this into a multi-view, this is effectively what we have. We have our front view, which is shown as if we were looking directly at the front view, a top view, which we see this top section here, and then we see this slope, but if we're like totally perfectly centered above the top, this slope is going to look like just a rectangle. And then same from the right side view, this right is right here in gray, and then the sloping section, if we were perfectly lined up, we couldn't tell that it would go back into the distance. So it looks just like a rectangle. So again, when you're drawing these drawings, you always want to make sure everything is lined up. So you want to make sure that your width stays the same on both your front and your top view. You want to make sure your height stays the same on your front and your right side view, because in reality the height is the same. And then your depth will stay the same. You can see the depth on the top view, and then you kind of have to make this 45-degree corner, but you can also see the depth on the right side view. So the most important thing with these multi-view drawings is that these dimensions have to stay consistent. So you actually will be drawing a straight line all the way across the bottom, and that's where you would draw your bottom edge for both the front and the right side view. Same for this, you would draw a line all the way down on the left side, which will represent the left side of your top view as well as the left side of your front view. So that's one important thing, is that these lines have to line up. And the second is that you always put the top on top, you always put the right on the right, you would put the left on the left, and you would put the bottom on the bottom. So orthographic projection is sort of the conceptual term for what we're doing when we're making these multi-views. And it's basically that you're projecting your features onto imaginary planes. So my analogy is, you imagine that your object is sitting in a glass box, and so your glass box has 6 sides, and then that, for example, the top view is projected straight onto the top of your box, and so then if you were to print the top of your box, it would be a projection of the very top of your object. So the glass box view is essentially each side of your box is a projection of a side of your object, and those box faces are what we are drawing. So again, the projection of features of an object onto an imaginary plane or a projection plane is considered an orthographic projection. In this case, we call it orthographic, meaning 90 degrees, because our box is made up of 90 degrees, our glass box that we're using. So if this is our object here, we can imagine we have this object sitting in a glass box. We decide what the front edge is. In the front, it'll actually be kind of back here, is what we decided. So we can draw the front, or sorry, this is our front right here. So we can draw the front. Then we can imagine we go up to the top. We look at the projection on the top. This is what we have. If we were to look at the projection from the bottom, this is what we have down here. See that the bottom is drawn on the bottom. The right side view would be sort of what's projected to the right wall. The left is what's projected to the left. And then the rear, it's as though your 6-sided box, you just sort of unfold that back side to the side, and then you have to unfold it again. So that's how the rear ended up far to the left. So this is a reminder from the pictorial sketching slideshow. We briefly talked about how to select the front view. So you want the object, or you want to choose the front that's going to be the most natural for use, that also shows the best shape, characteristic contours. Perhaps it's the longest dimension. It will have the fewest hidden lines, so it will be this object face that will most completely describe the object. And then you want it to be in a stable position. So I had used a stapler, my stapler for this example. This would be the logical front face. It's got the longest dimension. This is how you would use it. You're not going to have hidden lines from here, and then it's stable. It's not like you're resting it like this or something. It's stable this way. So I had shown this slide before as well, but we picked this to be our front view because it is the longest dimension, it has the best shape description, there's nothing hidden in the back, and it is sort of resting in its most natural position. So most of the multi-views I've shown so far here have had 3. We had that last example that had the 6 different images. The chair we had actually had 5. It had 4 multi-views, sorry. So deciding how many views to draw is also part of the process. You can get away with a multi-view that just has one view, which, yes, the word multi-view doesn't really apply. But you can do this if it is a uniform thickness or uniform shape. So in this picture on the left, there's a note there that says 1/8 inch flat stock. So that means that it's just a flat piece that's been machined to this shape. So in that case, you can imagine our multi-view is going to be really boring. So we can actually get away without drawing the multi-view, especially if we have that note about how thick it needs to be. So then this drawing on the right is actually a round piece. So you can imagine it's sort of like a spark plug. It's completely symmetrical. The front view is the exact same as the top view. The back view is the bottom view. The only thing that might be different might be the right side or the left side view, which is just going to be a set of concentric circles. But essentially we can understand what that would be. We don't necessarily need an extra view because everything we need to know is already shown in this picture. We could also get away with just using 2 views. Again, if we have a symmetrical part, meaning that if we had a third view, it's just going to be a repeat. It's going to be identical to any other views. But we do need a second view if we have to describe something about the depth. So in this case, we have to show that that circular part actually has an increase in height. So we do need that for depth, in this case, height. Okay, so when we are sketching multi-views, we assume that we generally have the overall dimensions, so the length, width, and height, and then we can just sketch it out using construction lines and then darkening with object lines. So again, I definitely recommend using a ruler for these. And also this is good with graph paper. Regular 90-degree graph paper is best for these. So the first step is to lay out boxes within the individual views that we're going to make using points and construction lines. So these 2 lines are going to represent the front and the right side view. And then that's going to sort of represent the width of our front as well as our top view. And then those will represent the depth of our right side view. And then those 2 lines are going to represent the depth of the top view. And then you can see that they'll sort of come together. If we've drawn this correctly, those will connect at a 45-degree angle. So here in yellow is where we're actually going to draw our object multi-views. We've got our top, front, and right side. The top is going to be on the top, front in the front, and right will be on the right. So here's what I have here. I'm using construction lines to sort of figure out where everything should go. But this line here represents that top edge that you can see from the front view. And then you can see that this line connects here. And then this is a construction line that represents this this edge, the right side of my front view, which will also represent this right side view, sort of this piece right here before the cutout. You can trace that up and you can trace that over, and you see that they still have to intersect. You will be able to see this in our top view as well, and they have to sort of cross over at that 45-degree line. So we can also identify any visible edges with object lines. So again, this might be kind of tricky, but you can always erase if you are using pencil. But we can darken up some object lines we have here. So our front view is the easiest. It's just shaped like an L. And then the top view, if we've drawn enough of our lines, you can see every line here that we draw on our top view can actually connect to something in our right side view. So that's a good check to make sure that everything sort of connects, each feature connects to the same feature. So like this part right here is this little protrusion. You can see it exists here. If you follow these lines, oh, this is the protrusion right here. So by following the lines, they sort of point to the same feature in both the top and the right side view. Step 4 is to locate the hidden lines. So that would be something that you can't necessarily see from that particular view angle. So if we're looking at our front view, we wouldn't be able to see this cutout because all we can see is this L shape. So we would draw a hidden line to represent the bottom of that cutout. We can't see the other cutout either, so we can add that hidden line. Oh. And that's it. Those are all of our hidden lines. We don't need to add any more. From every other view we have here actually completely shows all of the object lines. So if we wanted to, we could go through and sort of lighten any construction lines or further darken our object lines. But otherwise, that's our complete multi-view. Okay. So take a second to ask yourself, what's going on with these 4 objects here? They have the same overall dimensions, so same length, width, and height. They have the same color. They're made out of the same material. What else might they have in common? So think about their multi-views. If the front edges are, say, this darkest gray is going to be the front edge, those front views are all going to be different. If you think about the right side view, this one has a polygon here. We've got our circle with an arc here. This right side view would actually just look like a square. This right side view would look like 3 rectangles. But then let's consider the top view. And the cool thing about these multi-views is that in a top view, especially for something sloped, remember we had that sloped example before, if we're perfectly centered over the top, these slopes are just going to look like rectangles. So both here and here, these slopes just look like rectangles from the top view. These obviously look like rectangles because they're flat. And then even a rounded arc just looks like a rectangle. So in the end, these all have the same top view. It's just going to look like 3 rectangles. So that's one thing to keep in mind with multi-views is even if the surface is sloped or rounded, the view is going to look flat. So sometimes it's difficult to sort of see. That is sort of a drawback, is that you can't quite tell that depth, how that depth changes, especially if you don't have shading, which you wouldn't put shading on a multi-view. But that's also an advantage because it sort of more clearly shows what that object looks like in terms of manufacturing. That's it for multi-views. Good luck.